Okay, so I rummaged around for some little knobs. There we are there. This one is the most appropriate one, if I can fit it on here. Needs a little bit of shaping inside. How would I do that? This hard plastic. Anything here. Fall right off though. Be a sharp little screwdriver. Knife or something like that to I'm just trying to cut a slot in here. Dremel. Go to the dentist, ask him to do this. He's probably got a way of doing it. Well, not really getting anywhere here. Where am I? Little bits of plastic coming out. Hey, that goes on quite a ways. On you go. There we are. Okay, let's start this guy up here. See, I didn't get the very top of this. This is what people look at on the radio, right? They look at the front. They look at the dial. Those are the things you want to make sure look as good as you can get them. That's a little better. Okay, let's turn it on. Okay, currently radio is off. Just make absolutely sure. Hey, how come the tubes are lighting up? On, off. Maybe the clock has caused it to come on. Let's fool with this. Haven't done anything with the clock yet. Should be off. Should go off. Go off. Oh no! Don't tell me. It's a great radio. You just can't ever turn it off. I thought this worked. pushing and shoving. Huh. It's interesting. I push it in. It doesn't do anything. Nice knob. Drat. I thought I found that switch working. I might be doing more on this radio here. So I won't push these in all the way. How do you like that? Doesn't want to quit now. Actually, it's a nice... Downtown Toronto. That was almost certainly 680. It's supposed to be off right now. Set it to off. Turn the timer all the way around. Well, what can I tell you? It's a little bit disappointing. That's about all I can do with it right at the moment. I'm way behind. 11:15, I gotta run. Okay, we'll have to leave it at that and ponder it. Maybe the owner has something to say about it. That's it. Thanks. Okay, radio's back out of the cabinet. Let me just plug it in here. Somehow I had convinced myself, I don't know how, the switch worked. So this should not come on. Oh yeah, then all the tubes are lit up. So that's off. That's on. That's off. That's the automatic clock control. Usually these things snap, you know, when you hit the right time. This is right in here. I see some kind of movement there, but okay. So the switch, let's see. Oh, a switch, I see it up underneath here. Let me just shut this off so I don't picking up a live chassis again. This radio is plugged into a isolation joint, so I really don't have much to worry about. Let's see the switch there, eh? Yep. Looks like it should be moving this plunger. Let's get a closer look. Looks like something broken right there. The switches, yeah. So there should have been a piece coming across here. It's simply broken off. So let's see, this is the on position. So yeah, you can see that's stuck in the on position. Better than stuck in the off position. How are you ever going to fix that? I mean, this material is broken because it's weak already. Oh my gosh. Supposed to drag it all the way up there, and then it's got to be a sliding kind of deal here. Like this tang, metal tank cannot grip fast the plunger part because of the you know, this is rotating, it's changing position relative to the upper part, so you can't fuse that to this. Whoa! I spent a long time getting the knob on this thing too. What do you do about this? Put an additional on-off switch mounted on the back of the radio. That probably explains why when I turned the alarm setting, it didn't seem to behave right, because probably this has to be in the alarm position to hear the trigger go. So in other words, you never use this as an alarm clock, but then who really would use this as an alarm clock at this point in time? You really need the on-off switch. You really, just in case I didn't sound quite clear, you really need an on-off switch on a clock radio. Otherwise, you're plugging it in and unplugging it every time you want to turn it on and off, and what kind of time is your clock going to keep? It just nullifies that it's a clock radio. Somebody who's going to buy this is going to want it sitting somewhere with that clock going. And then occasionally impress their friends by switching on the radio. Okay, so that being the case, somewhere there must be some switch wires coming over to the coming over here, hidden in this big box, somewhere way up inside there. So here's some wires. Here's some wires coming out of the cardboard box. Oh, is that my phone going off there? Let me just apologize. I have my phone in my pocket, which sets off the video sound sometimes. Okay, so these wires come up, come through this hole down there. That's 1, 2, 3, 4 wires coming through there. But it's the ones coming out of the clock here that have got to be the ones of interest. It's these 3. They're all going through on an angle. They come out on that same angle there. They head this away. And one goes right to the power wire. That white wire down there is coming right up here to the power wire. How much you want to bet this terminal on this tube is spare? Pin 1. And then the other terminal comes over to here. See, there's a capacitor connected there now. They wouldn't connect a capacitor to nothing. I'll bet you, well, it's going to be 1 or it's going to be 6. 1 or 6 on the Which tube is that? That's the rectifier tube. 1 or 6, of course, got the power lines coming to it. Pin 1 or 6. Pin 1 or 6. There you go. 35. It's a 35W. 35W4. Pin 1 is spare. No connection. Pin 6 is where you would take off power to run a light. There is no light. I don't exactly know what they're doing with pin number 6, but pin 1 is the one I'm interested in. No connection. So that's what they're doing. They're using this as a terminal. So those wires are the switch wires. So if I can cut those wires way up here, in fact, pull them back, shove them out the back here, and mount a switch. Mount a switch on here. An itty bitty switch, maybe. Let me get out some switches here. We'll take a look. Just fishing through my drawers of switches. Here's what I've got for switches. Okay, so I got these guys. So that's just an on-off switch. 8 amps, 125 volts. Can you believe it? 8 amps through that. So that would work nice. I got these. These are ooh, triple pole, triple pole. No, these are double throw, double pole. So that's overkill. Just need that. So that can sit back here, sticking out. Look at that. I can actually mount it right there. Don't even have to put in a washer like that. That should hold it. Put it one on either side. That should lock it up against here. Tighten it down good. We're done. Pull the wires out. Push them through some little holes here. We're done. Sounds easy as pie. Now if I cut those wires, am I going to cut the power to the clock motor? Oh. It shouldn't. There should be another wire. There should be another wire in here. Whoop, 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 whoop. Another wire, eh? So there's got to be a wire, well, 2 wires really, feeding that motor. One of them can come from the negative bus. And the other one would have to come from the unswitched terminal. That would be this one. Okay, this isn't making sense now to me. Made a lot of sense a moment ago. So this white wire must be conveying power to the clock motor. Should not cut that wire. Then the radio, where would the radio, how's this going? This is so simple. It's so simple, Jim. This black wire, little black wire here, think is, see, it's tying to the power here. I think it's coming around and picking up the first tube. I think this will answer this question. No, that black wire. No, that's the ground bus. That's the negative bus. I'm lost. I'm totally lost. I just don't want to do the wrong thing here. It's a little like when you're a news reporter, you're supposed to get the story and they could get a separate confirmation before you publish. Same kind of thing here. The first story you get, for me anyway, quite often it's totally wrong. They need a corroborating story here. So, okay, 35 Z5. Heaters are 2 and 7 with 3 in the middle. 2 and 7. So 2, okay, yeah. So 2, one wire is connected right to 2. 7 has a wire going right down towards the clock. I'm just all turned around in my head here. So the power wire comes in, connects to 2 and 1. 1 is nothing to do with the 2, but the 2 is the heater. That's a terrible way of drawing it. Okay, so 2 is the heater. Now, 2 also is the B minus. Runs all around the radio. 7 is 2 and 6. Wasn't it? Wasn't it 2 and 6? Two. What happened here? I got a totally different chart here. 3 and 4. 35 W4. I think I looked at a 35 Z4. I think that's what I was doing. Yikes. Okay. If I was a doctor, people would lose their lives for sure. 35 W4. Pins 3 and 4. Okay. That's it. Pins 3 and 4. Totally different story coming now. Maybe that's why I was getting all turned around. Pins 3. Okay, now we're back to the ones I was looking at earlier. Pins 3 and 4. Extra light. I'm sure there's nothing connected. That 4. 1, 2, 3, 4. 4 has nothing. Come on. How can that be? The brown wire clearly goes to 3. 4. What the heck? What the? Six. Well, they could be pulling a stunt here. Wow, is this really the case? They're going to use half the heater? Am I totally... No, this has to be the rectifier. It's got the power wires coming to it. 35W4. just lost my mind completely. 35W4. No, not completely. Still a little more to go. Okay, once again, the simplest thing in the world I'm trying to sort out here. So we have a pin with no connection. Pin number 3, around hidden almost from view, is a brown wire going to it. Next pin over is pin number 4. Pin number 4 has solder on it. You can see a wire on it. It's got to be in there. It just must be so tight in there. That little nubbin of black wire. I'm just totally nuts. Oh, wait a minute. Wait a minute. What's going on? They got pin A. Okay, it's all cleared up now. 2 pins soldered together there. So 3, 4, and 5 are soldered solidly together. There's still no wire going to it. Four and 5. Four, 5 is a plate. I thought they might have soldered together 4 and 6. None of this makes any sense. Oh my gosh. I certainly have a way. Wait a minute. Wait. Let me look at this again. The heaters, definitely not 2. Oh, 1 and 2 have no connection. Interesting, and they've used 1 and 2 to catch the end of the power cord. 1 and 2. They're connected to nothing though. 3, 4 are the outside of the heater. 6 is the center tap. 6 has a bunch of stuff hooked up to it. One, 2, 3. They got 4 and 5 stuck together. What's the matter with me? So my parents used to ask me all the time, "What's wrong with you?" I must have heard that. I must have heard that a lot. Along with, "You're not using your head." That was another famous one my dad used to throw at me all the time. And when I started using my own head, they didn't like it. Okay. let's take another close look here. I just can't believe what I'm seeing and what I should be seeing are two entirely different things. Look, this was supposed to be another 5-minute fix it up thing. I thought I was going to spray a little WD-40 on a switch and be done with it. So really carefully now. Pin 1, power cord. Pin 2, power cord. Pin 3 is a piece of brownish wire similar to what I see running to the heaters on other tubes. So let's just take a look. Here we are in another tube. There's the brown wire. Pin number 3 and 4. See, 3 and 4 both have the brown wire. That's the heater wire, that brown stuff. See it coming off of the back of pin number 3. Now, there's pin number 6 all by itself over there. So that leaves between 3 and 6, that leaves 4 and 5, and they are soldered right together. Is there something I just don't know? That there, I don't get it. Maybe everybody else, maybe you get it. Maybe you who are watching this, you get it. I don't get it. I can't possibly be getting this wrong. 1, 2, 3, 4, 5. Soldered together, nothing else happening. Plate of the rectifier tube. Wow. Plate of the rectifier tube. So, I mean, if this makes sense to you, then you're wondering why I am totally discombobulated, because I am. So that leaves 6. 6 is the center tap. Now, why would they bother? Capacitor going to basically to the B minus. So that other wire there from the capacitor wire on pin number 6 is coming back from the switch in the clock, which I'm pretty sure it is. There it is going down the drain to the clock. Then conceivably it doesn't make any sense to me. Then what? They're running half the heater? It doesn't make sense to me at all. And then with the open heater pin, pin number 4, they just went ahead and soldered it to the plate and then didn't hook any wires up to it. This is all just nonsense. So the plate should be where this red wire is here. It's got the wrong tube in it? How could it? It works. How could it have a wrong tube? So what is pin 7? Oh, well, pin 7 could be the cathode. I think I'd smarten up and leave this thing open at the right page. Yeah, so pin 7 is a cathode. So if I've got it right, you're generating the B plus there. And you have the plate tied to pin 4. going, what? Holy jumper. You know what? I can't figure this out. Guess I can approach it a totally different kind of logic here. And it should operate that switch. See if this power goes away to this pin. See right off the positive terminal here, there's a wire going right to the output transformer. It all makes sense. I don't know. I'm sorry. I gotta apologize because you're watching a video of me just totally stumped. Not that I don't get stumped with some regularity, but wow. I gotta stop and ponder this. Okay, so I took a look at quite a few schematics for what are commonly called All-American 5 radios, even though a lot of these were made in Canada too, all Canadian 5. There was a number of ways of dealing with the 35W4 rectifier. It is a center-tapped heater, but on the schematics I looked at, there was quite a few different ways in which the radios were done. But I did not see anything quite like this. So what I've done here is I've hooked up my voltmeter to the what I believe is the plate. I don't know. Plate and part of the heater. That terminals that are soldered together, and I'm just gonna poke around a little bit. We'll start with that, but I'll poke around. We'll see what we can see. Weird. I don't know. So let's power it up. We should see. Well, you know, this tube normally runs on 35 volts on the heater. If you only use half of the heater, because it looks like they've hooked up to the center tab. I don't know. I can't think it through. Let's turn it on. It's a mighty big voltage to put on your heater there. There's another 1 in the number. So I'm looking at whole line voltage right now. So I'm quite likely looking across the entire string. The voltage has dropped because I have the dim light bulbs in the circuit. So that's the supply voltage, 105. Okay, let's look at the other heater terminal here. Let me see, 83. So you take 105, subtract 85 from 105, you get 30. That's roughly the right voltage for there. Let's read the heater here. A little tricky with these clip leads though. Clip this one on. These radios are these small radios are more dangerous than the big ones. The big ones with the big power transformer. There's 120 volts available in various places in here. Okay, so that's the voltage dropping across the entire heater when read the way it's wired, which doesn't make any sense how it's wired. The voltage, I think, is coming, that's being switched by the clock here, the broken switch. I think we can read it here. And this basically is being stuffed into the center tap of the heater. Oops. if you shove 26 volts into half of a 35 volt split heater, you're supposed to be really shoving 15, 16 volts, not 24. None of this makes sense. Absolutely none of this makes a sense to me. Nothing is adding up. I love it. I don't come in here to not be challenged. I come in my shop to torture myself, basically. So the problem here is if I introduce a switch, I could introduce the switch so it fails to shut off the heaters. You know, and if I just interrupt these power lines, the actual incoming AC lines, I'll interrupt the clock. So it's something I've misinterpreted entirely. Yes. there is something I've misinterpreted entirely. I've now looked at this radio so long, the 3 wax capacitors, I should change them out. Maybe if I change them out, I'll discover what's going on, especially this one right here. It's right in the way. Okay, before I get a shock, I'm sticking my finger in there. That's what I'm going to do. I'm going to change out all 3 of these wax capacitors. And you know, I might as well do this one too. Do them all. Do the 4. And then we'll I'll stop mumbling at that point.